In previous lessons, we have learned how to add and subtract terms. And when we're adding and subtracting those terms, we're combining like terms. And then in our most recent lesson, we've started to learn how to multiply terms together using the product rule. In today's activity, we're going to put it together and practice determining when we need to combine like terms and when we need to use that product rule, because once you throw it in together and mix it up and have to figure that out, it can be a little bit more challenging, right? So in example number 1, it's asking me to simplify. So I want to take these 4 individual terms and make it as short as I possibly can. And I need to decide whether I'm going to combine like terms or whether I'm going to use the product rule. And I'm just going to look at these symbols right here, which tell me that I am adding these terms together or subtracting these terms together. When I am adding and subtracting, I am combining like terms. And as a reminder of what we mean exactly by like terms, those like terms need to have 2 important components. They need to have the exact same variable. So we can't put x's together with x's. We can't put y's together with y's. They've got to have the same variable. And something that we've discussed, but it's been a really long time, is that not only do they have to have the same variable, but if they have the same variable, those variables have to have the same exponents as well. So if I'm looking at the example that I have up here at the top, I'm going to highlight the sets of like terms that go together. So 5x to the second, it has an x, and it has an exponent of 2, which means that that is not going to be a like term with the 3x. Yes, they do have the same variable, but they don't have the same exponent. 5x to the second has an exponent of 2, but 3x does not. Remember, technically, if there's nothing sitting there, or no exponent, that means the exponent is a 1. Which means it's not a like term with 5x squared because it doesn't have an exponent of 2. So that means that 5x squared is going to be a like term with 4x to the second. And then if I look at my other terms that I have here in the example, I have a 3x, which I can combine with a 5x because they have the same variable and they both have the same exponent. Again, when there is no exponent there, you know that that is going to be a 1 for an exponent. So I can put them together. So I'm going to get these directions out of the way here for a second, give myself a little space to work with. And typically in math, we are going to work with the greater exponent first. So I am going to combine the 5x to the second and the 4x to the second. So remember, when you're combining like terms, the variable and the exponent stays the same. So once I combine 5x to the second and minus 4x to the second, it's still just going to be an x to the second. When you're adding and subtracting, you're really just dealing with those numbers in the front. And remember, those numbers are called a coefficient. So I have a positive 5 for one coefficient. I have a positive 4 for the other, or I'm sorry, I don't have a positive 4. I have a minus 4. Remember, minus and a negative means the same thing. So this is going to be 5 minus 4, x to the second. 5 minus 4 is 1. So that's going to be 1 x to the second. And remember that when we are simplifying, we want to get it as absolutely short as we possibly can. 1 x to the second is technically the same thing, but we don't really need that 1 there. And since the directions are telling us to simplify, that means we want to keep it as simple as possible. I'm going to erase that 1 because I don't really need it. So the next part of my expression that I'm going to deal with is the 3x. And that's a plus 3x because it's got a plus in front of there. And I'm going to combine that with a plus 5x. So when we're combining like terms, again, the variable doesn't change. So once we get done combining them, it's still going to be an x. So we do 3 plus 5 because we're doing 3 x's plus 5 x's. So that, friends, is going to give me a total of 8x. I cannot combine the x to the second plus the 8x because they do not have exactly the same exponent. So the final simplified version is 8x squared plus 8. And again, the reason that I knew I was combining like terms was because of these adding and subtracting symbols in between. When you have adding and subtracting, you are simply combining the variable and exponent that are exactly the same. Okay, now let's take a look at example 2. And this time we are not combining like terms. And the reason we're not combining like terms is because we've got our little dot right here in between those two terms. And that dot implies that we're going to multiply. And when we multiply powers together, we are using the product rule. So I'm going to give you a reminder of what that product rule means. So I'm going to show you the expanded form. So x to the second, remember, just means the same thing as x times x, because that exponent of 2 tells me how many times I'm going to be multiplying those x's together. And then x to the 5th power tells me I'm going to multiply x 2, 3, 4, 5 times because it's got that exponent of 5. And then the multiplication symbol that we have there in between tells me that I'm taking these two smaller multiplication problems and I'm just combining them together into one big multiplication problem. So remember the shortcut when you are multiplying powers together. All you do is step 1, the base, and the base is the big part. So in this case, it's going to be an x, stays the same. And step 2, you add the exponents together. So what the problem is asking me to do is, if I were to say kind of out loud what this problem means, it says, all right, I'm multiplying 2 x's and I'm multiplying 5 x's. I'm going to put this all together in one big multiplication problem. So how many x's am I actually multiplying together? So step 1, the base is going to stay the same. And step 2, I am going to add those exponents together. So that means it's going to be 2 plus 5, which means the fully simplified version of this problem is x to the 7th power. Example number 3, we need to decide whether or not we're combining like terms or whether we're using the product rule. So pause, think to yourself for a second. I'm going to give you a minute to think. Am I adding and subtracting, or am I multiplying here? Hopefully my at-home audience is saying that we are going to multiply. And the reason we're multiplying is because we've got that little dot that is sitting there right in between those two terms. So we are once again gonna take these two separate multiplication problems and put them together, and we're gonna do that using the product rule. Now this one is a little different from the last one that we did, because the last one we did just had the variables. It didn't have the numbers in front. It didn't have those coefficients. So I'm gonna do the variable part first, and then I'm gonna come back and I'm gonna deal with those numbers in a second. So we know that step one is that base is going to stay the same. So x and x are gonna stay in x, okay? We've got an x in both cases. And step two, we are going to add the exponents. A way of thinking about this, again, is that I've got two x's that I'm multiplying together, and I'm multiplying 4 x's. So how many x's am I multiplying all together? That's going to be 2 plus 4, which is going to be x to the 6th. Okay, so we've dealt with the variable. Now we need to talk about what we're going to do with those numbers in front of the variables. Okay, those numbers in front of the variables, by the way, are called coefficients. That's the big kid word for those for those numbers, in front of the variables. So the 9 and the 3. Now, this is still one giant multiplication problem. What a lot of kids have a tendency to do wrong when they're combining something like this is they think, oh, well, I added the exponents together, so I probably just need to add those coefficients together as well. And I get why that's confusing. We're not going to add the 9 and the 3 together. Instead, the coefficients should be multiplied, because those are just regular old numbers. The numbers are sitting next to the variables, which means multiply. And then you've got this multiplication symbol right in between. So that means you're going to multiply the 9 times the 3. So 9 times 3 is 27, of course. So now we're going to put it all together. So we multiplied those coefficients and got 27. We multiplied 2 x's together, then we multiplied 4 more x's for a total of 27 x to the 6th power. Okay, for example number 4, I want you to just pause for a minute. I'm going to shush for just a moment. Give you the opportunity to decide, are we adding and subtracting, or are we multiplying according to the way this problem is laid out? And hopefully you've had a minute to think about that. So clearly, we've got adding and subtracting symbols in between each of these terms, right? So because we're adding and subtracting, when you add and subtract, that is when we're going to just combine like terms. So I need to look for exactly the same variables and exactly the same exponents, and that determines what I can combine. The first thing I noticed really quickly though, and I kind of wanted to do a special one like this, notice right here that we are subtracting a negative number. And remember what happens when we subtract a negative number? That minus a minus cancels each other out, so that this really is going to turn into a plus. So I'm going to go ahead and rewrite that before I start combining like terms. And so now I need to look for whatever has exactly the same variable with exactly the same exponent. So I've got a 3x to the second. I've got another 3x to the second. And I've got a minus 2x to the second. So when we're combining like terms, remember the variable stays the same. So it's gonna, once we combine, all three of those terms, it's still going to be an x to the second, and we just add those coefficients together. So 3 plus 3 minus 2, 3 plus 3 is 6, 6 minus 2 is 4, x to the second, and then we have just the regular old 5x, and we don't have any other x's to combine that with, so it is just going to stay not combined with anything else. And so we don't have any more like terms. We do have the same variables, but we don't have the same exponents, so that means that this one is as simple as it's going to get. Okay, last example. Darn it, my cat's being obnoxious. Hold, please. Sorry about that. Cat was getting in the way. Okay, so lost my train of thought. Oh, yeah. So take a minute and see if you can determine whether we are going to be adding, subtracting, or multiplying. Alrighty, so hopefully we have been able to tell that this is multiplying for a couple of reasons actually, not just the little dot in between this time, but also because the x to the 7th and that x are sitting next to each other. So that also implies that we are going to be multiplying. So I am going to combine, so I'm going to use the product rule. Sorry about that. Product rule is when we're multiplying. And I'm going to go ahead and just deal with the x's first. So this means that I'm multiplying x by itself 5 times. I'm multiplying x by itself 7 times. And then whenever there is no exponent, there's technically a 1 there. So the x is going to stay the same, and I'm going to add those exponents together. So that means that I am adding, multiplying, a total of 13 x's. So that's going to be x to the 13th. Then I need to deal with those coefficients. So those coefficients are the big numbers in front of the variables. So we are going to multiply 3 times 4, which means that we're going to have 12 times x to the 13th power.